Hello everyone, welcome to our first video revising the unit circle. Well, you may remember before the mock exams we were looking at these special triangles. The first one was equilateral with a side of 1 unit, and the second one was isosceles right-angled with a hypotenuse of 1 unit. Sorry, it fell off the end there. That's a bit better. When we analysed these triangles, we found the angles 60, 60, 30, 45, as well as these lengths 1/2, √3/2, √2/2. And we put these lengths in the unit circle to define sine and cosine. Now sine is defined as the y-coordinate of a point travelling round the unit circle, and cosine is defined as the x-coordinate of the point travelling round the unit circle, always. What about tan? Well, since cosine is the x-coordinate and sine is the y, which we can see here, then it's easy to see that tan, which is sine over cosine, gives the gradient of the segment OB, joining our point to the origin. Tan theta is always the gradient of the segment OB. So with our special triangle, we superimposed it on the unit circle, giving these coordinates. So this is where the equilateral triangle goes. Therefore, this is cosine 60 degrees, and this is sine 60 degrees. And our other special triangle went here. Therefore, this is cosine 45 degrees, and this is sine 45 degrees. What's tan 45 degrees? 1, because it's a ratio of 2 equal numbers. And then we went on round the unit circle, filling it in like this, using the symmetry of the circle. We have A here because all the trig ratios are positive, sine, cosine, and tan. We have S here because only the sine coordinate, the sine ratio is positive. We have tan here because only tan is positive. If you look, for example, at this one, sine over cosine would give you √3 for tan. √3 is the gradient of this segment. It's also the gradient of this segment. So both 240 degrees and 60 degrees have a tangent ratio of √3. And of course, in this quadrant, only cosine is positive. So these facts help us navigate the unit circle. And here's a nice easy table which has a pattern to help you remember those ratios if you need to. It's obvious to see 0, 1, 2, 3, 4 is a nice easy pattern, and then you have it reversed here. The ones that aren't so easy to remember are tan, but once you know sine and cosine, you just make the ratio 0 over 1, 0. 1/2 over √3/2 is 1 over √3. √2/2 divided by √2/2 is 1, and so on. What happens here? At 90 degrees, the segment is vertical, therefore the gradient is not defined. In our next video, we will see how to use the unit circle to solve equations with trigonometrical ratios.